Welcome to the Breaking Boundaries podcast. I'm Annalise Riles, Executive Director of Northwestern University's Roberta Buffett Institute for Global Affairs. The Northwestern Buffett Institute is dedicated to breaking through traditional silos of expertise, geography, culture, and language to surface novel solutions to pressing global challenges.
Today's topic is near and dear to my own heart ever since I personally experienced life in Japan after the meltdown of the Fukushima Daiichi nuclear power plant in 2011. We're here to talk about the risks surrounding disasters at nuclear power plants. Those are risks to health, the environment, and to communities. Now, this has become all the more urgent over the past year because we've seen the weaponization of what was once thought to be a purely peaceful use of nuclear technology, as Russian troops have threatened Ukraine and the world with using military means to cause a nuclear disaster at Zaporizhzhia. So here to share insight on the impact of past nuclear disasters, how Russia's war on Ukraine brings to the surface the threat of more nuclear disasters, and how emerging technologies can help us combat these threats, is Dr. Gayle Woloschak. Gayle is the Associate Dean for Graduate Student and Postdoctoral Programs at Northwestern University and a Professor of Radiation Oncology and Radiology at Northwestern University's Feinberg School of Medicine. Gayle studies the effects of radiation from nuclear disasters as well as from everyday and medical exposures. Welcome, Gayle, to the program. So glad you're with us.
Thanks, Annalise. Thanks so much for having me. It's always a joy to talk with you.
So, Gayle, first let's talk about you. You have devoted your life's research to these questions. Tell us a little bit about what is your connection to this set of topics. Why did this interest you from the start?
Yeah, it's kind of interesting. I mean, radiation was one of those serendipitous things. I never planned to go into radiation. I took a course in radiobiology when I was in undergraduate school, but I never really thought I'd go into it. And then I found myself at Argonne National Laboratory as a molecular biologist. And slowly, they pulled me into the field. And the thing that attracted me was that it was like you could have physics, biology, chemistry, medicine, epidemiology, all in one. And it was that interdisciplinary nature of the field that really got me excited. So here I am.
And what's your connection to the current situation in Ukraine?
Well, I'm of Ukrainian background. My grandparents all came from the western part of Ukraine. Ukrainians have this thing where we're sort of like Ukrainian forever. So I know my cousins over there. I visited there many times. And in fact, one of my cousins is a refugee in my home right now. And we have a refugee scientist from near Mariupol who works in the lab. So I have a lot of connections. I've grown up in the Ukrainian community all my life.
So, Gayle, for those of us who are not scientists, what is radiation? What counts as high exposure? What's low exposure? What are some of the risks associated with radiation? Walk us through the real basics here.
You can divide radiation into two types. What we are talking about is ionizing radiation. Ionizing radiation breaks chemical bonds. Non-ionizing radiation is things like the ultraviolet radiation from the sun. It's like your cell phone, it's cell phone towers, it's the electromagnetic fields that we're exposed to. That UV radiation is somewhat dangerous. Most of the rest are not dangerous and have not been shown to pose any. So now let's think only about the ionizing, only about the ones that break bonds. Those are going to include the therapeutic radiation that people get in the clinic when they're receiving radiotherapy, say for a cancer. They include the CT scans that people are exposed to. But they also include radiation that comes from accidents like Chernobyl and Fukushima. And they include our natural background radiation, which we are exposed to all the time. So our natural background is generally pretty low. There are some areas of the Earth's crust, like Ramsar, Iran, that are very high. But even that is relatively low compared to where we would find biologic effects. So where do we find biological effects? If you got your entire year's exposure in 100 years, and you lived 100 years to get that all in one pop, then you would have a risk for developing cancer that is measurable. That's not to say that any dose isn't of concern, but it's hard to measure those doses that are much beyond that 100 years total background dose.
What would be an example of something that would give you a dose of that level?
If you are exposed, say, for example, for Chernobyl, The people that went in to handle the radiation accident, they got pretty high doses of radiation, could get lethal doses. But if you were living in Kiev at the time, there were much lower doses that are still well above background that could have caused an increased risk of cancer. To be honest with you, Kiev was a very interesting case because we did see some increased risk of thyroid cancers, but not many other cancers were increased following that. One other thing to note is that when we give radiotherapy, we're giving a very, very, very high dose, but generally only to one part of the body. If you were to get that total dose to your entire body, you would certainly die within moments or an hour at least. So it depends on how the dose is delivered that matters too.
So, Gayle, your lab, the Northwestern University Radiation Tissue Archives, is believed to be the world's largest collection of irradiated animal tissue samples. Can you tell us a little bit about this collection? Why is this important? What is its value for research?
Yeah, the story of this collection's really amazing. Department of Energy during the atomic bomb era, they actually ran experiments across the entire US with 49,000 mice, 24,000 dogs, 30,000 rats. And when I was at Argonne, because I was at Argonne before I came to Northwestern, they kept those for about a year, and then they threw their portion of it, which was the mice, in a trash barrel. Somebody called me up and said, Gayle, they're throwing out all these tissues in the trash barrel. And we had worked with them when we were still at Argonne. So I called up Department of Energy. They shipped them to us. We have all the tissues and we have all the data sets. We make the data sets available worldwide. We make the tissues available worldwide so that people can analyze them. And we have techniques now that they didn't have 30, 40, 50 years ago when they generated these animals. So we can look at them with new eyes. Statistics are new. Informatics is new. We have X-ray microscopy, which didn't exist at that time. So we're doing brand new experiments with this old archive. So it's really kind of cool and it's a lot of fun.
That's fascinating. So now let's turn to the 1986 disaster at the Chernobyl nuclear power plant in Ukraine. And I know you've been to this site many times. You have many contacts there. Tell me some of the lessons that you believe the scientific community has learned from that event and what it tells you about how we can prevent or recover from future disasters.
So I actually went to Chernobyl soon after it blew. Argonne sent me to do some analyses there. But the then President Bush had planes that he was flying relief efforts, and I flew relief efforts into the entire area near Chernobyl. So I went there a number of times. I think we've learned a lot about reactor safety after that. In the immediate aftermath of Chernobyl, we learned that certain reactors are not so safe. So one reactor that was not that type makes both nuclear energy and nuclear weapons. We only had one of that type in the US, but we decided that was not good. We immediately closed our one reactor that was like that, and nobody uses those reactors again. We learned that we need safeguards in place to prevent the kinds of accidents that happen at Chernobyl. We learned that emergency preparedness means that you have to tell the people right away. In Chernobyl, they waited for weeks before they told the people about the accident. They did not give out potassium iodide tablets, which would have prevented probably all of the thyroid cancers that develop. So we learned that that was important. And of course, our US government stockpiles potassium iodide now, and there's a run on potassium iodide in Ukraine right now. Another thing that we learned was, I think we thought before that transplantation was going to be a good way to treat some of the high dose people that were exposed. We learned that failed way too often in Ukraine, and we've gone only with treating with biologicals rather than actually treating with transplantation. And then finally, I think one of the more important lessons was about geography, that radiation doesn't know borders. While the reactor was in Ukraine, Belarus and Russia both got hit with radiation. And so that's even what we need to think about with Zaporizhzhia. When Russia's thinking about blowing up that reactor, it's not going to stay in Ukraine's borders. It's going to go where the wind goes. So I think those are the major lessons that we learned from it.
So let's talk about Zaporizhzhia. So in March 2022, the nuclear power plant in Zaporizhzhia, Ukraine, was occupied by Russian forces, and the United Nations and the International Atomic Energy Agency have come out and strongly condemned the occupation and expressed concerns over the staff's ability to communicate with outside people as well as the status of the plant and its safety. And we've seen a number of episodes of losing power, going on backup generators, and so on. What is your knowledge of the state of safety inside the plant, and what are your concerns about this?
The safety at the plant before the occupation was really strong. Zaporizhzhia was probably one of the most secure of all the nuclear reactors. Now, nobody really knows what the safety is like inside. I've seen reports from the IAEA. They're unclear. They keep asking for clarification on what is going on within the plant. The electricity is often cut off to the plant, which means that things like the monitors for radiation are not functioning. And one of the problems that the population believes is how would they know if there's an accident? Most of the radiation effects, you don't experience them until 1 or 2 months after you've been exposed. Sometimes it's years after you've been exposed. So fortunately, the IAEA, along with WHO, help to fund people to have monitors with them so they can monitor the radiation as it comes out, if there is any. But there were no monitors at that time. The ones in the plant are not working. So far, it looks like there have been no release from the places where they've been monitoring, but I think that's a very big risk. Having a population that doesn't know that anything happened would be a very big problem, I think. You would talk about things like radiation sickness. I mean, not just risk of cancer 20 years downstream, but you'd be talking about risk of radiation sickness at this time. And in some cases, intervention in those instances would save life. So it makes a big difference.
So you were just talking about the situation at Zaporizhzhia. I think many of us who read in the news about the power failures and so on aren't really sure how serious this is. Do you have any comments on how close this reactor has been to facing some sort of crisis?
I don't really know how close it's been, but I can say that the power is absolutely essential to keep the power plant running and safe. The towers, most of the material is cooled by having electrical power to the power plant. They have only so much generator power, and so when you take away the electricity that actually feeds into the plant, now you risk overheating, which was exactly what happened at Chernobyl. Risk having a repeat of what happened at Chernobyl. The exact status, though, I don't think anybody knows. I mean, IAEA has not been in there for a while. I don't think we can get good access to it. And most people consider it to be a sort of dangerous war zone, and access has been very difficult.
And what do you know about the conditions of the workers inside the plant, whether there are sufficient numbers of people, what kind of condition they're working under, and so on?
In the beginning of the war, they were being held at gunpoint, which is utterly ridiculous. These jobs at power plants are very, very stressful. There's the need to be constantly monitoring things. I mean, people's lives depend upon it running correctly, so you can imagine the kind of stress that there is. But what I do know is that I've heard that the gunpoint component to it is no longer there, but they have Russian workers in now instead of Ukrainian workers. And I don't know if the Russian workers are trained to work on that particular power plant because some of the power plants in Russia are different from this power plant. They've had to be retrained in some cases. I don't know how expert they are at being able to do the work that they do. I've talked to several of my friends in Kiev who worked with Chernobyl, and they are very worried about what's going on in Zaporizhzhia in general.
So you were a delegate to the United Nations Scientific Committee on the Effects of Atomic Radiation. What is this committee? And tell us a little bit about what its work has been like since the beginning of Russia's war on Ukraine.
I was appointed by the State Department, actually, to be a member of this committee. It's a scientific committee, so we don't normally deal with political issues. It started in 1955, and it involves all the nuclear nations of the world who come together and talk about risks of radiation exposure. Most of our job is about preparing these giant scientific reports on particular topics. And Russia, of course, is at the table, and Ukraine is at the table. The discussions can be very, very difficult. The scientists themselves are, they managed to get along, but the past couple of years, since Russia's been waging its war on Ukraine, the beginning of the session, which is an open session, and the end of the session, which is also an open session, have had not just the Russian scientific delegates, but the Russian ambassadors have come. And they've made horrible comments about how Ukraine is the aggressor. They've made comments about how the EU is not being fair and how they're treating Russia. They've made comments about how in Japan, they're dumping radioactive waste into the ocean without permission, which is not true. The permission was granted by the UN to do that. So it's just a horrible thing. And this last year, it got so bad that the scientific chair of the committee didn't know what to do. She had to suspend all discussion and bring in some of the ambassadorial staff to help us navigate the situation. It was incredible.
I am very proud to be a peace correspondent for the city of Nagasaki. And as such, I care a great deal about ensuring that Nagasaki is the last city that ever experienced the horror of a nuclear bombing. So I'd like to talk with you a little bit now about nuclear weapons and the radiation issue around those. I know you go to Hiroshima at least a couple times a year. Tell us a little bit about your work on that side, on the nuclear weapons side.
Yeah, so actually, I was just a few weeks ago made chair of the Scientific Advisory Committee for the Radiation Effects Research Foundation in Hiroshima. It's the group that oversees all the studies that are done with the Hiroshima and Nagasaki atomic bomb survivors. It's a very important work that's being done where they're collecting tissues from those that are deceased. They're continuing to collect data from those that have lived through it. It's incredible. I'm going again in November. I'm going to visit the Radiation Experimental Research Foundation, and we'll give a seminar there and meet with some of the staff and work with them. I also had the rare opportunity to meet with one of the survivors of the atomic bomb. His name is Kodama. It was kind of cool because he wrote a book about his experiences. It's called Hibakusha, which is the name that they have for the atomic bomb survivors. This man was amazing. He has survived 6 cancers, probably most as the result of the Hiroshima explosion. He traces the route that he took after the accident. It is just a fascinating story. But the most amazing thing to me was that he cried, I cried, we hugged each other. He has no bad feelings toward Americans at all. And I was just so impressed with his ability to discuss these things after everything that he's been through. That's been my experience with the atomic bomb survivors. Amazing people.
Well, that's exciting because we're going to have some of those folks coming to Buffett in just a few weeks. So hope to involve you in that. So how did the aftermath of the bombings of Hiroshima and Nagasaki inform our scientific understandings? I understand that quite a lot of U.S. research was done immediately after those bombings.
Yeah, I think it wasn't immediate. It was probably within the first decade or so after the bomb was dropped that it began. In fact, it's rather sad it didn't begin sooner because there are a lot of things we missed about radiation effects. But the US and Japan drew up a treaty, and the treaty was that we would continue to fund research to examine what had happened with the atomic bomb survivors in hopes of understanding radiation effects. I mean, it's the largest population that's been studied to date for radiation toxicities, and almost all of our risks that we associate with cancer come from that population. It's really a large scale. And there are also things like effects in utero that have been done, effects to like lens of the eye for cataracts. So almost everything comes from that. Now, there are other populations like Chernobyl, for instance, that people continue to study, but still atomic bomb survivors are the most important for determining all those sorts of things. And the work is still ongoing. There's a lot that's being learned all the time. For instance, one of the things that was really interesting that came out was that there are differences in sex for the development of lung cancer following radiation. Females were more at risk for developing lung cancer than males. And this was surprising, and it actually influences NASA because as the astronauts are thinking about going to Mars, they're worried about radiation risk to them and their experience when they go up to space. So the question was, do we not allow women to go to Mars for fear of their developing lung cancer? Decision was made to equalize the risk in some ways and not to stop women from going, but it was all based on atomic bomb survivor data. Very important.
So Russia has hinted threats of using nuclear weapons in Ukraine. And as a result, the Bulletin of Concerned Scientists has set the doomsday clock now at the unprecedented time of 90 seconds to midnight. If there were a nuclear power plant explosion at Zaporizhzhia, or if Russia were to use a nuclear weapon in this conflict, what would be the consequences, in your opinion, and what would be needed from a health perspective to address the humanitarian crisis?
Yeah, I think, first of all, it would be probably a lot like Chernobyl. I hope that if it does happen, the one positive could be that we could get people in there much sooner. We've learned a lot about radiation exposure in the world, and there are things we can maybe do to mitigate. So, for instance, what Ukrainians learned on the fly at Chernobyl was that they had to build shielding around the reactor that had melted down. We now know you must do that. And that lesson helped inform what happened at Fukushima, and it would help inform here, provided that we actually know what happened. We know better about evacuation. One of the things that happened that we learned from Fukushima actually was that we're evacuating to too low a dose. People died just because they were evacuated, and the risk of their getting a cancer was very, very low, and yet they were evacuated. The world has adjusted those doses a little bit. IAEA has worked on that. I'm also a member of the International Commission on Radiation Protection, and we've been working to set different dose limits for evacuation than we had before, so I think that that could also be done. For sure, potassium iodide would be distributed, but the key thing would be to know that the accident actually happened or that the event actually happened. One could imagine sabotaging the reactor and nobody knows that it happened. And without the proper monitoring, it could go for months in the population. That's why I think this effort that the IAEA and World Health Organization did to distribute dosimeters to the population is very, very important. It's a way of being able to monitor what's going on.
Tell us more about that. What was that effort?
Okay, so this just happened this past summer. It's not complete yet. Actually, when I was at the UN meeting, we always have representatives from the IAEA present, and they talked about the need to give monitors to the Ukrainian population because they couldn't trust that they would get readings from the reactor itself. So there was a big effort to distribute within all of Ukraine, not just close to the reactor, different kinds of dosimeters that could measure whether there had been any radiation that was released. They're still doing it. It's not a completed action, but it was funded by the EU. The work was done by IAEA and WHO.
That's really interesting. We saw something similar after Fukushima with handheld Geiger counters being one of the most popular kitchen tools. So now I want to ask you a difficult question, which is about the relationship between nuclear energy and nuclear weapons. Because this month, in fact, is the anniversary of President Eisenhower's famous Atoms for Peace speech before the United Nations General Assembly, which ushered in a view that we could have peaceful uses for nuclear technologies and really engage in developing those. But now Russia's actions at Zaporizhzhia seem to have, in some sense, weaponized the peaceful uses of nuclear power. So what do you think about this? And what can we do to really protect peaceful uses of nuclear energy to ensure that it is not weaponized?
Yeah, I mean, first thing I need to say, living in a radiation oncology department, one of the things that was envisioned in the Oppenheimer movie that was released recently is the need for using radiation to cure disease. And it's interesting that for Chernobyl, when Chernobyl blew, patients that developed the thyroid cancer, it was caused by radioactive iodine that leaked in the environment. And they cured it by giving people radioactive iodine to kill their cancer. Where the same idea goes on for the cause and the cure of the cancer. So there are lots of really good, peaceful uses of radiation that are important for life. Is nuclear power essential? I think at least right now, I don't think we can survive without nuclear power in the world. I don't see alternative energy strategies that are working so well. And yes, of course, it can always be perverted. What I will say is that there's a lot of work that's been done to try to mitigate anything that could happen. It's easier in the US where we have all kinds of protections in place, but you can't ever negate the fact of a bunch of foot soldiers coming in, taking control of a nuclear power plant, and then sabotaging it, as happened in Ukraine. In the US, we have a lot of safety policies. So, for instance, if there were to be a nuclear accident here in Chicago, whether it's a terrorist event or whether it's a power plant problem, there is a huge cadre. They do drills in the city of Chicago all the time for potential radiation events. The media is called in and is trained for what it means to have a radiation accident. The media calls people. In fact, I've educated some of the media about effects of radiation. About 10 years ago, there was a change in our training of radiation oncology residents. They never used to be trained in radiation terrorism. Now they are. So we've done a lot in the last 10 years to make ourselves here in the US more prepared and safer. I know that that's been going on in EU because I've taught in a couple of courses in the EU on this as well. I don't think it's going on in places like Ukraine and other Eastern European countries. I have not seen as much of it, but I think that would help at least to some extent. Does that solve the problem? No, but you can try to mitigate against it. I also need to say that our federal government is funding drugs, the development of drugs that will help to mitigate against radiation problems. And I actually lead a large program project. One of the members of my team has developed a new drug that will take plutonium out of the body. Those sorts of things are being funded by the government, and those will help, could provide some sort of mitigation were there to be an accident or an event that goes on.
Well, Gayle, this has been fascinating. You've shared so much information that is really hard to come by, and it's just an honor to have this conversation with you. I'm going to close with a question that I ask all my guests, which is, as you look at this situation, this conflict in Ukraine, and in particular, the issues surrounding the place of nuclear power in that conflict, what are you most worried about and what gives you hope?
So I think I'm most worried about the political problem here in the US that might take away support for Ukraine and undermine efforts that we're having in the US. Right now, I think that's what makes me lose sleep at night is the sort of political swaying that goes on in the US. But the thing that gives me the most hope is the academics in Ukraine who are persisting, who are continuing. I have collaborators still who are working despite everything. Some are serving as help for the hospital, but others are trying to continue with their scholarship and their work. I had the chance to work with 8 Ukrainian scholars in Greece this summer, and despite everything that was going on, they were hopeful and optimistic and excited to learn. That kind of human desire just can't be held down even by a war. So that gives me hope.
Well, Gayle Woloschak, it gives me hope to have a colleague as remarkable as yourself. Thank you so much for sharing your time with us today and for the remarkable work that you do.
Thanks so much, Annalise. It was great to talk with you.